Today in geometry, we're going to look at our word problem applications. We're going to be dealing with lateral areas, surface area, and volume. All right, so number one, Lisa wanted to paint her brown flower box purple. Using the given dimensions, how many square inches will she have to paint? So we see that this is a rectangular prism, but we're not going to be painting the top, right? So it's a rectangular prism with only one base, okay? If we paint the bottom, if we want to paint just the sides, then we're looking at lateral area. So lateral area of a rectangular prism is simply the perimeter times the height. So our lateral area would equal 22 plus 22 plus 8 plus 8 times the height 10. So I add 22 and 22 and 8 and 8, I get 60 times 10. So the lateral area would be 600 square inches. If she wanted to paint the bottom as well, then we would want the surface area with only one base. And so that would be our lateral area, 600 plus the area of one base, so 8 times 22. So now I'm at 600 plus 176, which would be 776 square inches. And number two, the Campbell soup can is 6 inches tall and has a radius of 2.5 inches. Okay, so soup can, we're a cylinder. Okay? So it's 6 inches tall, radius of 2.5. How much paper is needed to make the label? Remember that our label goes around the can, right? Not on top and bottom. So that is the lateral area. The lateral area of a cylinder, 2 pi times our radius, 2.5 times our height. So when I multiply all of that together, I can say it's either 30 pi square inches, or multiply 30 times pi and I get 94.2 square inches. And then it says how much room is there inside the can to hold the soup. So that's volume. So volume of our cylinder is pi times our radius squared, 2.5 squared, times our height, which is 6. Multiplying all that together, and I get 37.5 pi cubic inches, or multiply 37.5 by pi, and I get 117.8 cubic inches. Right, number three, Brian wants to paint his living room and kitchen the same color. His living room is 35 feet by 60 feet, and his kitchen is 20 feet by 45 feet. How many gallons of paint does Brian need if 1 gallon of paint covers 400 square feet? Okay, so right here I see square feet, so that tells me that I'm looking at area. We're not talking about surface area or lateral area. We're just talking about the area of a rectangle, right? The wall, okay? The length times the width or the height. So the area of the living room is going to be 35 times 60, which is 2,100 square feet. It's a huge living room. The area of the kitchen is 20 times 45, which is 900 square feet. So the total area that he's going to paint, add those two together, and I get 3,000 square feet. So that's just his kitchen and living room. So Brian lives in a pretty big house. All right, so we have 3,000 square feet that we want to paint. 1 gallon covers 400 square feet. So divide 3,000 by 400, and we get 7.5. We can't buy just part, like half of a gallon. So we're going to say 8 gallons of paint is what Brian needs to buy to paint both his living room and his kitchen. Right, number 4, Macy delivers muffins for the Muffin-O-Matic Muffin Company. Each muffin is packed in its own little box. An individual muffin box has the shape of a cube, measuring 3 inches on each side. Macy packs the individual muffin boxes into a larger box. The larger box is also in the shape of a cube, measuring 2 feet on each side. How many of the individual muffin boxes can fit into the larger box? So this is volume. How many can fit inside? Volume. So first, let's find the volume of each individual. Remember, volume of a cube is just the side cubed. So 3 cubed gets me 27 cubic inches. But notice that the larger box is measured in feet. So let's go ahead and change our cubic inches into cubic feet. Remember, in order to do that, I know there's 12 inches in a foot, so I have to cube 12. So I know that there are 1,728 cubic inches in a cubic foot. So each of the smaller individual boxes are 0.0152625 cubic feet. The volume of the big box, 2 feet, so 2 cubed is 8 cubic feet. So now I want to know how many boxes of the little boxes fit in the big one. So 8 divided by 0.0152625 gets me 512 boxes. So she can fit a lot of the little boxes into the great big box. Number 5. The pedestal on which a statue is raised is a regular concrete solid measuring 9 feet long, 9 feet wide, and 6 inches high. How much is the cost of the concrete in the pedestal if the concrete costs $70 per cubic yard? Per cubic yard, volume, right? Cubic. Notice I have feet, inches, right? And then yards. So first thing I need to do is change the 6 inches into feet. So divide by 12 inches, and I know it's half a foot. So I'm going to find the volume in feet. It's a rectangular, so rectangular prism, so 9 times 9 times a half. So the volume is going to equal 40.5 cubic feet. I'm selling concrete by the cubic yard, so I need to change 40.5 cubic feet to cubic yards. Remember, I know that there's 3 feet to a yard, so I cube 3, so there's 27 cubic feet in a yard. So 40.5 divided by 27, I have 1.5 cubic yards of concrete that I need for this statue pedestal. It costs $70 a cubic yard, so 1.5 times 70. It costs us $105 to buy the concrete to make this pedestal for our statue. All right, next page. David and Karen are building a treehouse in the shape of a rectangular prism for their daughter. If the treehouse is going to be 5 feet tall, 8 feet wide, and 7.5 feet long, how much space will there be inside? Space inside, that's volume. So first, let's find the volume of this. So 5 times 8 times 7.5. So there's going to be 300 cubic feet inside. Then it says, how much space will they have to paint on the outside? If we're just painting the outside, we're just painting the surface area of this. It's a tree house, so we would assume that it would have a floor and a roof. So we want the surface area of the entire rectangular prism. So the surface area, our perimeter, so 7.5 plus 7.5 plus 8 plus 8 times its height, 5, plus 2 times the area of the base, 7.5 times 8. So when I add 7.5, 7.5 plus 8, I get 31. So this is 31 times 5. Multiply these 3 numbers over here, I get 120. 31 times 5 gets me 155 plus 120. So the surface area that they need to paint is 275 square feet. On the front, we learned that 1 gallon paint covers 400 square feet. I only have 275 square feet to paint. So 275 divided by 400, they only need 0.6875. They can't just buy that, so they need 1 gallon of paint to paint this treehouse. All right, number 7. This pencil cup is made out of plastic. It is 5 inches tall and has a radius of 1.75 inches. How many square inches of plastic were used to make the cup? All right, so square inches is telling me area. Okay, it has one base on the bottom, right? The other base is open so that we can put pencils in it. So really, this is a cylinder with only one base. So I want the surface area of a cylinder with one base. So the surface area of a cylinder says 2 pi times my radius, 1.75 times my height, 5. Plus, usually it would say plus 2, but we don't want 2 bases, so we're just going to do plus 1. So pi, my radius, 1.75 squared. So if I multiply all of this together, I get 17.5 pi. Plus 1.75 squared gets me 3.0625 pi. So add them together, and I get 20.6 pi square inches, or I can multiply that out. 64.6 square inches of plastic were used to make that cup. All right, number 8. Gary has a super jumbo-sized drip coffee maker. The beverage is produced as hot water filters through a cone-shaped vessel. So, draw my cone containing coffee grounds. The cone has a height of 3 inches. The height straight up and down the middle. The diameter of 1 foot. Okay. I notice inches and foot. Okay. I'm going to go ahead and change the foot to inches. So 1 foot is 12 inches. Assuming the cone is filled with water and the water is dripping out at a rate of 10 cubic inches per minute, how long will it take for all of the water to pass through? Again, cubic inches, volume. So I'm going to find the volume of this cone. How much water does this cone hold? So volume of a cone, 1/3. So let's get rid of all of that. So volume equals 1/3 pi times my radius. So the radius is going to be 6 inches squared times the height of 3. Multiply all of that through, and I need to go ahead and multiply by pi since I'm going to have this conversion here. And I have 113.1 cubic inches of water that's in here. It passes at a rate of 10 cubic inches per minute, so I'm going to divide this by 10. And I find out that it's going to take 11.3 minutes for all of the water to pass through. All right, our last example. Paul has been working out by lifting weights. He finds that a spherical lead alloy weight with a radius of 3 inches weighs 20 pounds. He wishes to lift 100 pounds, so he special orders a spherical weight with a radius of 15 inches. Why is Paul in intensive care? Well, let's see. A sphere, okay? So the whole thing weighs 20 pounds, so volume. So the volume of the first one, 4/3 pi times the radius 3 cubed. Gets us 113.1 cubic inches. The volume of the one that he orders, 4/3 pi times 15 cubed, is equal to 14,137.2 cubic inches. I can look at how much bigger is this volume than that one. So 14,137.2 divided by 113.1 gets me 125 times bigger. So the one he ordered is 125 times bigger. If the first one was 20 pounds, and the next one is 125 times bigger than that, so 20 times 125, the one that he ordered weighs 2,500 pounds that he's trying to lift. So that's why he is in intensive care. All right, so that wraps up some examples of word problem applications with lateral area, surface area, and volume.